Good morning. So in the last class, we discussed about the Laplace transforms, those properties of Laplace transforms, and inverse Laplace transforms, and some problems related to Laplace transforms and inverse Laplace transforms. Right. In the same manner, we will discuss about the jet transforms. What is jet transform? What are the types of jet transforms? What are the properties of jet transforms? Okay, and inverse jet transforms and ROC, region of convergence. Okay, the properties of region of convergence here, and some problems related to jet transforms and inverse jet transforms. Right. So what is jet transform? How it is expressed mathematically? So jet transform is nothing but jet transform of x of n. Here we are taking the discrete time signals. Okay, in the case of Laplace transforms, so Laplace we have taken the Laplace transform of x of t, right? That is nothing but x of s, which is equal to integral minus infinity infinity x of t into e power minus st dt. Like that, that was expressed mathematically. So, but here these jet transforms are expressed as a discrete time signals, right? That is x of n. X of n is the discrete time signal. So the jet transform of this discrete time signal x of n is defined as x of z. Okay, so x of z is expressed mathematically as sigma n equal to minus infinity infinity x of n into z power minus n. Okay, so x of z equal to z transform of x of n, which is equal to sigma n equal to minus infinity infinity x of n into z power minus n. Let it be considered as equation number 1, or we can say that z transform of x of n is x of z, right? Z transform of x of n is x of z. Okay, so it is referred as, here it is varying from minus infinity to infinity. That's why it is called a two-sided z transform, or bilateral z transform also. Okay, so this above equation is referred as bilateral or two-sided jet transform of the sequence x of n. Here we are taking the jet transform for the sequence x of n, right? So it is shown diagrammatically as here x of t. This x of t is the input signal. This sigma n equal minus infinity infinity delta of t minus nts is nothing but the train of impulses. Okay, these two are multiplied. So x of t is multiplied with the train of impulses. We will get discrete time signal. Okay, distant instance of time, that is a discrete time signal excess of t. Okay, right. So that is the, like that we will get the discrete time signal. So x of t is this one. Okay, this will be multiplied with the train of impulses, that is sigma n equal minus infinity infinity delta of t minus nts. These two will be multiplied so that we will get the excess of t or x of nts is like this. Okay, so the range of values of z for which x of z expressed by the equation number 1. What is equation number 1? That is sigma n equal to minus infinity infinity x of n into z power minus n. Okay, the range of values of uh, z for which x of z expressed by the equation 1 approaches to a finite value is called the region of convergence. Like Laplace transform also, we have the region of convergence that was defined as the range of values of sigma. Sigma is nothing but the real part of the complex variable s, right? So the range of values of sigma for which integral minus infinity to infinity or 0 to infinity mod x of t into e power minus st dt must be less than infinity. So that must be a finite value. Here also the equation number 1, that is sigma n equal to minus infinity to infinity or sigma n equal to 0 to infinity x of n into z power minus n will approaches to a in some finite value, that is called a region of convergence. Okay, next coming to x of n. How to get the original signal x of n? By taking inverse jet transform of x of n, that is inverse jet transform of x of z, so that we will get x of n. Okay, so here z inverse is nothing but inverse jet transform. Okay, next, in the same manner, we have the unilateral jet transform, that is x of z is equal to sigma n equal to 0 to infinity x of n into z power minus n, or we can express this as sigma n equal to minus infinity to 0 x of n into z power minus n. So this is unilateral jet transform, whereas the above equation number 1 is bilateral jet transform. That was expressed as a sigma n equal to minus infinity to infinity, whereas in unilateral jet transform, sigma n is varying from minus infinity to 0 or 0 to infinity. Now we will see the relation between jet transform and Fourier transform. So Fourier transform of discrete sequence is nothing but the special case of jet transforms. So the relation between Fourier transform and jet transform is like this, is as follows. So if you take the jet transform, that is x of z is equal to jet transform of x of n, that is sigma n equal to minus infinity infinity x of n into z power minus n. That was already discussed. Okay, where what is z here? Z is nothing but the complex variable. Let us express this complex variable z in polar form for our analysis purpose, or for our simplification purpose. We will express this z into polar form, that is magnitude and phase angles form. So that is z equal to r into e power j omega. That is equation number 2, where r is magnitude of complex variable z and omega is angle of complex variable z. Right, now we will substitute this equation number 2 in equation number 1. Instead of z, replace z by r into e power j omega, so that the equation number 1 will become uh, x of z is nothing but r into e power j omega is equal to sigma n equal minus infinity infinity x of n into z is replaced by r into e power j omega whole power minus n, right? So we know that Fourier transform of p of n is equal to sigma n equal to minus infinity infinity p of n into e power minus j omega n. Okay, that is equation number 4. Now we will compare the equations 3 and 4, so that jet transform of r into e power j omega, or x of r into e power j omega, is equal to Fourier transform of x of n into r power minus n. That is, jet transform of x of n is equal to Fourier transform of discrete sequence x of n into j r power minus n. If r is 1, magnitude is 1, then it will become Fourier transform of x of n. Okay, the magnitude of z is 1. Okay, so mod z equal to 1, then z transform reduces to Fourier transform. So z transform at r equal to e power, or at z equal to e power j omega, it means that r value becomes 1. If r is 1, then it is r into e power j omega, so it will become e power j omega, right? So z transform at z equal to e power j omega is nothing but Fourier transform of discrete time signal, that is Fourier transform of x of n. So x of z at z equal to e power j omega is equal to Fourier transform of x of n. Thus, z transform reduces to Fourier transform along the unity circle in complex z plane as shown as. So here, this is the unity circle. So here ROC will be drawn like this. So this is imaginary axis and this is real axis. With the radius 1, we will draw the unit circle. This is unit circle having the radius 1. Okay, so this is z equal to e power j omega. Actually, z is r into e power j omega, but here r is unity. That's why it is represented like this. R is 1, so this is 1 into e power j omega with a unity circle like this, right? Naturally, for an arbitrary dt sequence or discrete time sequence x of n, the sequence x of n into r4 minus n may converge for only specific values of r power n, may converge for only specific values of r power n. Therefore, x of z will converge for certain range of z, which will be referred as ROC, the range of values of z for which sigma n equal to minus infinity infinity x of n into z power minus n must approaches to finite value. That is called ROC, or region of convergence. If a region of convergence of Z transform includes unity circle, then the sequence X of n is also Fourier transformable. That is, ROC of right-sided sequence always lies outside of circle of finite radius R degrees. Okay, so if ROC of X of n includes unity circle, then X of n also Fourier transformable. Okay, the region of convergence of X of n includes unity circle, then it is Fourier transformable. Okay, so see the simple problem. Find the Z transform of a finite duration sequences given below. Okay, we have to find the Z transform of the sequence, that is the sequence given a bit as X of n is equal to 3 4 5 8 9. It is a set of 3 4 5 8 9, and b bit is given as a set of 2 8 1 3.5 6 3. Okay, here but arrow mark is given at here. It means that 5 is nothing but X of 0 value, 4 is nothing but X of minus 1 value, and 3 is nothing but X of minus 2 value. In the same manner, 8 is nothing but X of 1 value, and 9 is nothing but X of 2 value. In the same manner, for the b bit also, here 3.5 is nothing but X of 0 value, 1 is X of minus 1 value, 8 is X of minus 2 value, 2 is X of minus 3 value. And here, here 6 is X of 1 value, and 3 is X of 2 value, right? So how to do this one? So we'll see the solution. From the definition of Z transform, how the Z transform is defined? So Z transform of X of n is equal to okay. So from the definition of Z transform, so Z transform of X of n is sigma n equal to minus infinity to infinity X of n into Z power minus n. Okay, Z power minus n. See, in a bit X of n is given as 3 4 5 8 9. Here X of it is varying from minus 2 to plus 2. So sigma n equal to minus 2 to 2, right? So here X of minus 2 value is 3, X of minus 1 value is 4, X of 0 value is 5, X of 1 is 8, and X of 2 is 9. So n is varying from minus 2 to 2. So X of Z equals sigma n equal minus 2 to 2, X of n into Z power minus n. So what is X of minus 2 value? That is 3. 3 into Z power 2 plus 4 into Z power 1 plus 5 into Z power 0, that is 1. Okay, 5 into 1, 5 plus 8 into Z power minus 1 plus 9 into Z power minus 2. So this is the Z transform of the given sequence 3, 4, 5, 8, 9. Okay. For the second bit also we'll do the same manner, that is X of minus 3 is 2, X of minus 2 is 8, X of minus 1 is 1, and X of 0 is 3.5, X of 1 is 6, and X of 2 is 3. Okay, it is equal to n is minus 3 to 2 X of n into Z power minus n. So it is 2 into Z power 3 plus 8 into Z square plus Z in, now 1 into Z power 0, that is 1. So 3.5 into Z power 0 is 1. So 3.5 into 1, that is 3.5 plus 6 into Z power minus 1 plus 3 into Z power minus 2. So therefore, ROC of the above two signals is entire Z plane except at Z equal to 0 and Z is infinity. So it is in between 0 and infinity because these two are finite time sequences. Okay. So in the same manner, we can do the we can find the Z transform of the finite term sequences given as X of n equal to set of 1, 2, 3, 4, 5, 6, and b bit is X of n equal to 3, 0, 7, 0, 16, 0. Here X of 0 is 1, X of 1 is 2, X of 2 is 3, X of 3 is 4, X of 4 is 5, and X of 5 is 6. In the same manner, in the second bit also, X of 0 is 3, X of 1 is 0, X of 2 is 7, X of 3 is 0, X of 4 is 16, and X of 5 is 0. Okay, so it is varying from 0 to 5. And the third problem, find the jet transform and sketch ROC for the discrete time sequence. Discrete time sequence. Okay. So here the sequence given is x of n equal to u of n. What is u of n? It is unit step function. Okay, it is varying from 0 to infinity. So how it is defined mathematically? So u of n is equal to 1 for n is greater than or equal to 0, and is 0 for n is less than 0, right? So here it is varying from 0 to infinity. So n is varying from 0 to infinity, u of n into z power minus n. What is u of n? U of, from 0 to infinity, u of n value is 1 only. That is 1 into z power minus n. So it is z power minus n. So we can write this as z power minus 1 whole power n, alpha power n. It is like alpha power n. N equal 0 to infinity, it is in the form of sigma n equal 0 to infinity alpha power n. So alpha power n is nothing but it is a geometric series with the common ratio alpha, that is 1 plus alpha square plus alpha cube up to alpha power n. That is what geometric series with the common ratio alpha. Okay, what is meant by common ratio? It is nothing but the ratio of second term to the first term. What is second term here in this series? Alpha is the second term. What is first term? 1. So it is alpha. So common ratio is alpha. Is the ratio of the second term to the first term. Okay, alpha by 1, that is alpha. So the geometric series will converge for mod alpha is less than 1. Okay, then sigma n equal 0 to infinity alpha power n is nothing but 1 by 1 minus alpha. Sigma n equal 0 to infinity alpha power n is nothing but 1 by the alpha. Okay, for the mod alpha is less than 1. Okay, for mod alpha is less than 1. So in our, okay, in our problem also alpha is nothing but z power minus 1. So x of z is equal to 1 by 1 minus z power minus 1. Okay, 1 by 1 minus alpha. It is like 1 by 1 minus alpha. So 1 by 1 minus z power minus 1, or z power minus 1 is nothing but 1 by z. Okay, by taking LCM, this is z minus 1 by z, or it is nothing but z by z minus 1. Mod z power minus 1 is less than 1, or 1 mod 1 by z is less than 1, or z is greater than 1. Mod z is greater than 1. Okay, so its z transform is x. Z transform of u of n is x of z equal to z by z minus 1, and its ROC is mod z is greater than 1, right? So the ROC of this problem can be represented as this is the ROC. See, this is the imaginary axis and this is real axis with the unity circle. So for every sketch of ROC, we have to note the unity circle. Unity circle, okay? So this is unity circle. So mod z equal to 1. So but here ROC is mod z is greater than 1. So we have to sketch the ROC beyond this unity circle. Okay, beyond this unit circle, right? Okay. So up to here, its radius is 1. So beyond this, we have the ROC, region of convergence. So this is jet plane, and beyond this unity circle, we have the ROC. Okay. So this is about the sketch of ROC. Okay. So for this unit step function. So next problem is x of n. When the transform sketch the ROC for x of n is equal to a power n into u of n. This is the next problem. A power n into u of n. So what is the transform? This one, x of z equal sigma. That is the formula. X of n equal sigma n is minus infinity x of n into z power minus 1. But here also u of n is there. U of n is varying from 0 to infinity only. From 0 to infinity, its value is 1. So that it will become sigma n equal 0 to infinity a power n into 1 into z power minus n. So that is a power n z power minus 1. Or we can write this as a into z power minus 1 whole power n. Sigma n equal to 0 to infinity a into z power minus 1 whole power n, that is in the form of alpha power n, alpha power n, sigma n equal to 0 to infinity alpha power n. So its solution is 1 by 1 minus alpha. Here alpha is a into z power minus 1, right? So x of z equal to 1 by 1 minus a into z power minus 1, and its ROC is mod a into z power minus 1 is less than 1. So it is a by z minus a by z. So z by z minus a, or a by z is less than 1. So z is greater than a. Okay, z is greater than a. So and its ROC is like this. So this is unity circle. This is unity circle. This is imaginary axis, and this is real axis. This is z plane. So this is unity circle. Z is greater than a. If this is a, then z is greater than a. Beyond a only we have the ROC. Right. This is the sketch for a for n into u of. Next, find the Z transform and sketch the ROC for the discrete time sequence. Discrete time sequence that is given as x of n is equal to minus a power n into u of minus n minus 1. Okay. See, x of n is given as minus a power n into u of minus n minus 1. Right. So for this we have to find out the Z transform. So x of z is equal to Z transform x of n, that is sigma n is minus infinity infinity x of n into z power minus n, or x of z equals sigma n equal minus infinity infinity minus a power n into u of minus n minus 1 into z power minus n, right? Okay. But here it is given as u of minus n. Suppose if it is u of minus n, then it is varying from minus infinity to 0. If it is u of n, it is varying from 0 to infinity. But here it is given as u of minus n minus 1. It means that it can be shifted by 1 unit, shifted towards left by 1 unit. That is sigma n is varying from minus infinity to minus 1 up to minus 1 only. It appears its value is 1. Okay, u of minus n minus 1 means from minus infinity to minus 1, its amplitude or its value is 1. So integral minus infinity to minus 1 will become minus a power n into 1 into z power minus n. Or we can write this as sigma n equal minus infinity to minus 1 minus of a into z power minus 1 whole power n, right? Let p equal to minus n. Say minus p equal to n, then x of z will become sigma n is minus p, so minus p tends to minus infinity to minus 1 minus of a into z power minus 1 whole power minus p, right? Is it not? Or we can write this as sigma p equal to infinity to 1 minus of a power minus 1 into z whole power p. Okay, like this. This is alpha power n. So it is equal to sigma p equal to infinity to 1 minus of a power minus 1 into z whole power p. Here we are adding and subtracting 1 for this expression. So it will become minus of a power minus 1 into z whole power p minus 1 plus 1. Okay. So we can take minus as common, minus of 1 plus sigma p equal to infinity to 1 a power minus 1 into z whole power p plus 1. Okay. This one can be written as minus of a power minus 1 into z whole power 0 plus sigma p equal to infinity to 1 e power minus 1 into z whole power p plus 1. Okay. So this entire expression will be written as sigma p equal to 0 to infinity a power minus 1 into z whole power p plus 1, or it will become 1 minus sigma p equal to 0 to infinity a power minus 1 into z whole power p, right? So but sigma p equal to 0 to infinity alpha power n, it is in the form of alpha power n. So it is equal to 1 by 1 minus alpha. So 1 by 1 minus a power minus 1 into z, or it is equal to x of z is 1 minus 1 by 1 minus a power minus 1 into z, and mod a power minus 1 into z is less than 1. So by taking LCM, so a minus z by m minus z by a, that is 1 minus a minus a by a minus z, and z by a is less than 1, right? So that it will become minus z by a minus z with z is less than a, okay, mod z is less than a, or we can write this as z by z minus a with the mod z is less than a, okay. So the transform of minus of a power n into u of minus n minus 1 is z by z minus a with ROC mod z is less than a. So here the ROC will be like this: if a is less than 1, mod a is less than 1, then this one is mod a is less than a. If a is greater than 1, okay, a is greater than, then its ROC is like this, okay. Okay, like this we can draw the ROC for the jet transforms, okay. Right. With this, we have discussed the definition of jet transform, two-sided jet transform or bilateral jet transform, unilateral jet transform, its ROC, region of convergence, okay, and some problems related to jet transforms, okay. So with this, I am concluding the today's class, and the next class will continue the next problems, okay. Thank you. Thank you.